Alright, everybody in their places. You guys ready on acid?
Ready on acid.
Ready in the blender?
Ready in the blender.
Tenfold. Go ahead and swap me the acid.
Let's get it Hotel, wake up call, got me getting up.
Today I'd like to go over the Fracsim oscilloscope. I'm sure a lot of you are wondering what does a well service technician even need an oscilloscope for. I can tell you it's a tool that is often overlooked in our industry, but is still a very valuable tool if you know how to use it correctly. And it can speed up how long it takes you to solve an issue, and it can also help verify quickly that that's what the issue actually is. It gives you information that, you know, a fluke meter measuring frequency just won't show you. So some of the reasons I have, and I can tell you from experience that I have several times used each of these, or used the oscilloscope for each of these examples, but some of the stuff, you know, checking to see if serial ports are active on a unit, or not specifically a unit, but just equipment in general. I mean, you can look at it with a multimeter, but it's not quite the same. You can use it to see if turbine flow meters are spinning and generating a good signal. So if you lose rate on the blender on a job and you just want to know if a turbine flow meter is spinning or it's got a chunk of stuff jammed in it, you know, you can very quickly hook up a 2-pin or even a 3-pin isolated with the Fracsim, look at it through the scope, and you can tell if that flow meter is actually spinning or not. You can verify unit to unit rate signals are healthy, working correctly and at the right frequency. You can bench test your magnetic pickups to see if they're working correctly. And like I mentioned before, it just shows you stuff that measuring frequency with a multimeter does not show you. And I'll go over that later on when we do some examples. Now, what does the Fracsim scope offer? Now, first thing you should know is that, you know, the scope on the Fracsim meter is not the same as a top-end bench scope, but it is simple to use, and people not familiar with oscilloscopes will have no problem operating this. It is very simple. You don't need any extra stuff as long as you have your Fracsim with you. It uses the same measure leads, so there's no problem there. It gives you your min and max peak readings, plus your hertz and your duty cycle if you want. It has an auto or manual operation, and the limitation of it is it is only good for 200,000 samples per second. And you can see a decent wave up to about 10 kilohertz. You know, you can see some stuff higher than that, you know, 20 kilohertz, 30 kilohertz. You can see it, but it's such low resolution that it's not very useful. But in our line of work, you know, turbine flow meters spin at like, you know, a few hundred hertz. You might have encoders going up to a couple thousand, maybe even 5,000 hertz, but that's easily seeable. And even serial data, you have no problem looking at serial data at 19.2 baud or even higher than that. You have no problem looking at that. So next I'd like to go into some operation of the oscilloscope. So turn your meter on. It's pretty straightforward. It's already on here, but I'll turn it on. And what you do is you go to your measure function and then press F4. That's your oscilloscope. Now, like I said before, it just uses your probe leads, so you don't have to change anything. Just stick your probe leads on, and you're ready to go. The keypad functionality, if you want to increase your voltage base, you press the down arrow. That's because that'll make the wave smaller. And if you want to decrease the voltage base, you press the up arrow here. You don't have to press shift. You can just press 8, and it will go. Right now it's 8. I just pressed it. It'll go to 4. And then the left and right arrows are used for your time base. So 6 is a smaller time base to make the wave larger, and 4, or the left arrow, will actually make the time base larger. And if you press any other key, this portion freezes. The actual oscilloscope, it just shows you like a screenshot of what it was looking at. But this screen pops out and it shows you live frequency measurement of what's going on. And you also give you the option for if you want to see AC, DC, and your trigger level. trigger level is based on a percentage of the scale. So if you press any other key, it'll bump you back out of there. And the other function you have is you got your, see it says F1 auto in the corner there. If you press that, it'll go to auto mode. Your voltage range is on the side, and then your time per division is right there. So if I were to press auto right now, it goes to a waiting on input, figures things out, and there's nothing hooked up, so it's just trying to look at noise right now, which is not going to be very, very successful. You might be looking at 60 Hertz from a wall outlet right now. The first example I'd like to show you is looking at serial data. So out of my computer right now I have RS-45 data, and we're going to hook up and measure that. Now before we hook up, I just want to show you something. These are the voltage levels for RS-45. So the top, the max is 5 volts for a positive signal, or that'd actually be a 0, and it has to be between this 3 volts here and that 5 volts there, so it has to be between 3 and 5, and the system will accept that as a value it can interpret. And on the low end it's between -3 and -5, so when you're looking at RS-45 it should always fit in that range there. And if you're one end or the other, I'd say in the +5 or -5, that's alright, but if you start getting down at +3 or -3, that would get you worried. Or if you have, you know, spikes that would represent possibly a capacitance in the system, you know, it could be a dirty cable. Stuff like that is what you want to keep your eye out for. So we're just going to go ahead and hook up and look at some RS-45 data. Take leads here right up to the output of the computer. We're in auto mode, so it'll give it a second here. She'll adjust, and there we go. Now I could leave it in auto, but I don't want to. Man, it is kind of drifting a little bit there. So take it out of auto. And I'm going to increase the time base a bit. So you can see the RS-45 data, and you can see the there you got 4 volts there and 2 volts there, so it's sitting right about say 3.75 volts, and you got -3.75 volts. Seems about normal. And if we were to zoom in a bit, it's got a relatively good corner on it, maybe a little bit of noise, but nothing serious. Now if you had a bad signal, of course, you would see something like, I'm just going to put my finger in between here, you might see something like that, where it's got all kinds of peaks on it, noise. That would indicate you have a bad cable of some kind. So the next thing I want to demonstrate is what a rate signal would look like. And we're just going to use a square wave to demonstrate an amplified signal after an amplifier, or using a 3-pin pickup. I'm not too sure what I have the voltage set to, so I'm going to increase the voltage range. And we got, looks like ±14 volts, which if we were more realistic we would actually have, I don't know, call that 12 volts. Now it's you see it's a nice square wave. The corners aren't rounded that badly. It's not going below 0. I have seen before you can have issues where if you don't have a proper ground, you can get an elevation between 0 and the bottom end, and that can be an issue with some systems. If your lower peak is not going right to 0, it actually won't trigger some frequency inputs, so that can be an issue as well. And of course you can, you could hit F1 to go to auto. it'll probably give us a very, very similar image. It looks like it shifted the time base one, and it shifted the voltage range up one as well. You know, you can turn it off and on, whatever. You could turn it on, get you close to what you want to see, turn it off, and then, you know, adjust it a little bit for your own liking. And at any time you can go over to this mode here and it'll show you the hertz. We're put on the let's put on the multimeter as well. So we're reading about 1497 there, and we got 1496 right there. This also shows you the maximum and the minimum and the duty cycles right there. Now, to get out of this menu, you would just hit any other key and it'll drop you back out. And since it is a DC only wave, we could actually press the AC DC and it'll change our screen over. So instead of showing a negative value at the bottom, it just shows a 0 and it's going up to a 14. And since we're in that mode, we can actually take it out of auto. We can actually bring it up a level, and we can get a little bit more detail on the top of the wave there. And I have particularly seen this issue before, this one I'm going to describe next. Basically, the complaint was a blender the rate output on the blender worked with some units and not other units. And you could hook up and you could measure the frequency correctly with a regular multimeter, and everything looked fine. But if you hooked up the scope, you saw something really peculiar. I'm going to demonstrate that now just by putting a bit of resistance in the line. I'll use my own body as a source of resistance. Actually, let me just change this back to AC mode. So now we're back in AC mode. And you can see what I'm doing, I'm putting a little bit of resistance in there, and the wave is actually turning into something, you know, just depending on how I'm holding it here, I can get the wave to do something completely different. And the tricky part is, you see this still right around 1500 hertz, and this is actually probably measured 1500 hertz, but you can automatically tell something ain't right with that waveform. And look, we went from a nice big 12 volt wave, now we're down to 8 volts, so depending on the switch point of your equipment. And the tricky part is, you'd never see that issue with a meter measuring hertz. It would still continue to measure the hertz correctly. The only way to spot something like that is to actually put on an oscilloscope and see it for yourself. And I'll just put it back the way it should be. And there's that nice square wave again. And then again back to a high resistance connection. And you can kind of get all kinds of funny waveforms going when you have dirty cables or bad connections. It just depends on exactly what's wrong.